Welcome, everyone. If you're taking AP Environmental Science this year, you are in the right place. I'm John from Marco Learning. I'm joined by the incomparable Kristen Shapiro. How are you doing, Ms. Shapiro?
Great, John. How are you?
I'm amazing. I am also don't know anything about environmental science. So when is this exam? Is it like a couple weeks from now? Is it 3 days from now? Is it
Exam
tomorrow?
is tomorrow at 8 a.m. local time.
So everyone's going to be taking it paper and pencil this year. It's going to be local in time. This is the 2022 exam. So if you are watching this video, Kristen, what is the topic we're going to be covering today that's going to help APE students get ready?
So we don't have one particular topic. We've just kind of identified the best tips and tricks and kind of top 10 things for you to cram after we're finished. So we kind of have a little bit of this and a little bit of that.
A little bit of that, a little bit of this. We also have a little bit of Mr. Smedes, who is, okay, can we badmouth Mr. Smedes for a minute? Like what I did a TikTok on our Marco Learning account talking about how he's an old man who goes to bed at 7 p.m. But both you and Mr. Smedes have been really involved in the AP Environmental Science community for a long time. You guys have been readers. What is that whole experience like? What are all the APES teachers like?
APES teachers are super nice. And we all just kind of gather around and we're grading your exams, but everybody is just so nice. And we're just there to make sure that students have a fair shot at earning a fair grade on their exam. And we're there to get to know one another and kind of hang out and kind of share best practices. Kind of like, hey, I do this lab. It's super cool. Why don't you do this lab? And so there's a lot of sharing and a lot of just kind of, hey, what does your class look like? And this is what my class looks like. And so Mr. Smedes is super great. He shares a ton and I share a ton. And so we're excited to be here to kind of give some tips that we've learned along the way to all the students.
Great. So I'm going to encourage you all, if you want to talk to Ms. Shapiro or Mr. Smedes as we go through this session, you've got the chat feature there. Mr. Smedes is going to be going live on his channel. Kristen, I'm going to turn it over to you. I'm going to hang out in the chat with my friends here. And if you like this video, everyone, press that like video, subscribe to our channel, and go ahead and post your questions.
All right. I do have a little bit of a PowerPoint that I think I'm going to share, or I'm sorry, the new kid's calling it a slide deck. So I'm going to share this slide deck really fast.
Looks good.
All right. So again, Mr. Smedes is going to be joining us soon. So I'm going to go ahead and get started. We're going to go over some logistics, and then we're going to go over a few topics. And then again, you're going to put the questions that you have in the chat, and we'll hopefully get started. Okay, so again, everything's going to be on this social media account. So we're super excited to be here with Marco Learning. This is my first time with Marco Learning, but I'm super excited to be here. And we'll go ahead and follow everybody on social media. That way you can see this. If you want to go back and watch it at a later time, it'll be there for you. I know some people maybe are taking a later exam. So it's a great idea to kind of follow everybody on social media so you have access. So again, your exam is tomorrow. You've made it. Your exam is going to be at school. It's going to be on paper. And it's going to have a multiple choice section, and it's going to have an FRQ section. So that multiple choice section is going to come first. And it's 80 questions, multiple choice. And from there, you'll have a little break, and then we'll move into the FRQs. So I know a lot of you are asking about FRQs, and we don't know the exact topic of FRQs. So I see that somebody in here has said like the FRQs is island species diversity. Abigail, who knows what those questions are going to be? They could be anything. So we aren't really sure what they are, but they are going to come out of some standards that we'll cover. And I'll kind of give you my top 10 things that I think might be on the exam. But again, we really don't have any idea. We do know, however, that the FRQs are going to be 3 different types. So we're going to have one of them that's about an investigation. So like experimental design. One of them is going to have either a data table or a graph or a figure of some kind for you to analyze. And one of them is going to have math. I know that somebody said on here that they are wanting a half-life review, so we can kind of go over that if we have time at the end. But you should definitely review experimental design, how to review figures, data tables, and graphs. And we have a few things on that. And we're going to review some math tips. In terms, I see some people are asking some stuff about cycles. Again, apes is a really broad course. We're probably not going to ask you to be like, write down the nitrogen cycle. We're probably going to give you a figure and ask you questions about it. So I wouldn't spend a whole lot of time super detail memorizing the cycles, but I would kind of have a general idea of what is this cycle, and most importantly, how do humans disrupt it, and how do we fix that disruption? All right, so all of your multiple choice have 4 answer options, A, B, C, and D. The first big part is to eliminate the distractors. So I tell my students, cover up the question and just kind of read through the answer choices. If the answer choices seem off the wall to you, like you know that that's not true, it's going to be a distractor, let's go ahead and get rid of it. Then we want to narrow it down to kind of 2 answer choices. 2 of them are going to be completely off the wall wrong. Hey, Mr. Smedes, how's it going?
It's going pretty well. How are you doing?
I'm great. Thanks for being here with us.
Yeah, absolutely. I will mute myself, let you carry on, and then I'll hop in when we get to FRQs. Looks like I made it just in time.
Yeah. So 2 of your answer choices are super wrong. 2 of them are going to be, one of them is going to be correct and one of them is going to sound correct, but if you read it really closely, it's going to be wrong. So your best bet is to eliminate out those distractors and then pick the best answer option. You have 80 questions in 90 minutes. So you have a little bit more than 1 minute per question. A lot of teachers really suggest that you go through, you answer everything that you know, and then you're going to go back and answer everything that you don't know. Make sure that you don't leave anything blank. It's in your best interest to answer every question. When in doubt, you're going to go with the answer choice that you can't find anything wrong with. Go with the thing you've heard your teacher talk the most about, because chances are there's a reason they were talking about those. All right, just a couple of reminders. Our exam content, we've got these science practices that you see on the right-hand side here, emphasis on the math for the FRQ, emphasis on visual representations and data, and then kind of in the middle of the screen, you're gonna see the topics. So Mr. Smedes and I like to say you should really focus in on 5 and then kind of 7, 8, and 9, or maybe 5, 6, and 9, because those make up over 50% of the exam. So if you're crash studying tonight, you're trying to cram everything in, focus in on 5, and then either 7, 8, and 9, or 5, 6, and 9. 9 is 20% of your exam, so that's really a high point to hit. Knowing legislation is going to be really great. I saw a couple of questions about the legislation, and that's going to be key, and I'm going to put that up here, so make sure you screenshot it when we get in or refer back to it. So there's 26 pieces of legislation that we have to know. So I'm going to go ahead and let Mr. Smedes go ahead and get started on our FRQ, because he's kind of like the FRQ guru.
All right. Hey, everybody. I don't think I actually have these slides open, so I might need some clicking through assistance.
I got you.
Yeah, excellent. We're going to make a good tag team here on the FRQ. So you want to break it down. You're going to want to annotate an FRQ. So I think that's step 1, if I remember correctly. But you're going to want to, again, make sense of it, break it down, annotate it, avoid ecoslang. So you don't want to say things are green. Oh my gosh, Ms. Shapiro, I'm sure feels the same way. Like when students say something's green or like clean, eco-friendly, it means nothing, you guys. And then third is probably going to have to do something with making sure that you are thinking like a reader, writing to the rubric. So we're going to talk about that more here, what it means to write to the rubric. So let's keep going here so we can do a sample annotation. And so as for a sample annotation here, or I should say like a task verb sheet, when we do the sample annotation in a second, the task verb sheet is going to guide you through this. So when you describe something, this is actually a little bit outdated. It says 2 sentences, 2 layers of detail. There's nothing magic about 2 sentences, 2 layers of detail. Same thing with explain. 3 sentences might even be a little bit long. 3 layers of detail. So I actually have an updated version of this that you can check out on the community page on my YouTube channel or in the Ultimate Review Packet. It's in the free preview, so you can check that out too. So if we move on, I think we actually have an example of how to do this. So what I recommend my students do, and there's a lot of ways to do this, the key caveat I want to give you guys is do not take forever to annotate. You can't just spend the whole time planning. Different teachers will tell you different things. I oftentimes have my students annotate for somewhere in the ballpark of 4 minutes per FRQ, write for 18-ish. 18 plus 4 is 22. 22 times 3 is 66. That gives you 4 minutes of wiggle room still to double check math, things like that. So that's probably a decent pace. But what you don't want to do is just launch straight into it. You don't want to launch straight into it, because what students do a lot of times is they write a great answer to a different question. And so if we hit the next button here, we can see a sample prompt that's going to come up. This is a pretty straightforward one. Identify 2 environmental benefits of a living green roof, suggested by council person Fassler. What I love about this little Easter egg, this is Amy Fassler, if I had to guess, a veteran apes teacher. And so that's fun. Just an Easter egg for you guys. Sometimes they name questions after famous apes celebrities. So she does the AP Daily live streams. But if you circle identify and you remind yourself one sentence, one complete idea, you can actually get away without a complete sentence if it's a complete thought, though. And in this case, we're going to do 2 of them. Make sure to separate them clearly. And then I like to bracket environmental and remind myself water, soil, atmosphere, plants, animals, habitats. You want to make sure you don't accidentally do economic, or you don't accidentally do like a human benefit. Humans are, even though we live in the world, we're part of the environment, we talk more about water, soil, atmosphere, animals, plants, and habitats. And then what is a living green roof? It's plants or a garden on your roof. So this is a pretty straightforward one, but it doesn't hurt to annotate it. So let's look at some language that we should be using here and language that we should not be using here. If we go to our next slide, I think we have Ecoslang on the left, apes equivalents to replace it with on the right. So don't say pollution. It's the bane of apes teachers' existence. Don't say green or friendly. Don't say harming plants or mess up. Talk about disruption of a cycle. Talk about specific pollutants, SOx, NOx, PM, carbon dioxide if you're talking about a greenhouse gas, not a pollutant, but a greenhouse gas. And so here are some things you can use to substitute in. I think if we keep going here, we have some of the major course ideas. So these are things that are likely to come up, you guys. Spoiler alert, you're going to see environmental impacts on tomorrow's exam. I promise. It's happened every year since 1999. Can almost guarantee there'll be an economic impact. I'm not going to promise that on 30 FRQ points, but it'll be somewhere. There'll be an economic impact on multiple choice or FRQ or both. Think about job loss or creation. Think about cleanup or repair costs. Think about wetlands absorbing stormwater. That's a go-to answer, or has been in FRQs past. And then, of course, humans have actions that disturb the environment. A pro tip is don't say a vague action. Be a little more specific. Deforestation for a purpose, to clear land for agriculture or for lumber. If you just say human action, deforestation, depending on the prompt, you run the risk of being a little bit too vague. And so that's just a great tip there.
Yeah, I want to add in 2 things here. Mr. Smedes is absolutely right? We're definitely going to see environmental impacts, and I would venture to say you're definitely going to see economic impacts, maybe not on the FRQs, but definitely in the multiple choice. And I think somebody asked a really great question. Usually ecological and environmental are roughly around the same things. We're really not going to ask you to distinguish between those 2 things, but you have to make those about the environment that's distinct or unrelated from humans. If you make that environmental thing about humans, then we're probably not going to give you points. What we really want you to concentrate on is what is that environment? How is that environment impacted? If it asks you for an economic impact, then we're going to go back to jobs and money. The kind of little one that I don't think is on here is an ecosystem service. So an ecosystem service, that is about humans. So that's kind of the ones that we want to distinguish. And environmental and ecological services. So environmental is about the environment. Ecological services is things the environment does for humans. So kind of make sure that we're familiar that ecological and environmental can kind of be the same lines, but economics a little bit different.
Yeah, very good distinction. You're right. The line between ecological and environmental, very, very thin. Every once in a while, you wouldn't necessarily want to jump to like a huge atmospheric issue, perhaps if you're talking about ecosystems. Ecosystems, you can keep it to the plants and the animals and the food webs there, but 9 times out of 10, they're going to be the same prompts. So if we keep going, I think we have chemistry review coming up here, and I'm actually going to pop out. I know this is a really brief appearance, but thank you to Ms. Shapiro here for walking you guys through this. She writes for the College Board here, you guys. So she is extremely knowledgeable about this. and she's going to tell you about chemistry, about math, and you're in good hands here. But I have to pop out and get ready for a live stream that starts in 14, however many minutes that is, on my channel. So I'm going to get out of her hair, and I'll see you guys all in 14 minutes over on my channel. Have fun. Chemistry, math, legislation. Woohoo!
Thanks, Mr. Smedes.
Yep. Bye.
Yeah, so I saw somebody say something about ecosystem services in the chat. So ecosystem services are things that the environment does for humans. Like forests, their ecosystem services are like oxygen for humans, or wood for timber, or food for humans to eat, or nutrient cycling. So those are all ecosystem services. If you're producing a good, we technically call it a provisioning service. If you're just out there hanging out, we call that a cultural service. But we probably won't ask you to distinguish the specific types of ecosystem services. We would just know what is an ecosystem services. I also see that some people asked about oceans and lake zones. Not really something that we're going to see a lot of questions on. We do need to know how humans are disrupting the oceans, and so that's going to lead us directly into this chemistry review. So what we see is that the pH is, remember that pH is on a scale of 1 to 14, and typically we see that environmental sciences, things are going to be being made acidic. So we need to think about acid rain. We're going to relate it back to parent material that's very acidic. We're going to talk about ocean acidification or acid mine drainage. And so those are all things that are caused by the pH being lowered. So here's a little hack. If they give you an acidic environment, we want to fix this. We want to add a base such as lime. So there's this pretty generic formula that we can look at, in which we have a pollutant like NOx or SOx, and CO2 is not a pollutant, but it's also emitted into the air. All of them react with water, and we're going to get out some type of acid. So carbonic acid, nitric acid, sulfuric acid. So those things make an environment more acidic, and we want to add a base such as lime in order to kind of bring that up, or a base such as limestone. The other thing that's really important for us to remember in our chemistry is that temperature and DO have an inverted relationship with one another. So as temperature goes up, that DO is going to fall. And so we can relate that back to sediment runoff. We can relate that back to climate change. We can relate that back to biomes and how we move in elevation. So please make sure that you understand that there's an inverse relationship between temperature and DO that's going to save you guys points. And then the last one is that chemistry for ozone depletion. Ozone depletion is when we have stratospheric ozone in the stratosphere. It's good for pale people that are like me. And so that is being depleted. Humans release a substance called CFCs. We find it in aerosols and coolants, and in the presence of UV light, that chlorine molecule pops off, reacts with the ozone, and I get out ClO and O2. And so that's actually the ozone being depleted. From there, we see that this lone oxygen is present. It reacts with that ClO to recreate the Cl and the O2. And that Cl is going to go on and repeat itself. And so the big thing is, if you know an environmental problem, do you know the solution? And so coming back, our solution is the Montreal Protocol. We already talked a little bit about acid rain. You can see the formulas there. Those are definitely something that I would review. And we would also review stratospheric ozone formation, right? So we've got cars. Cars are releasing NO2 in the sunlight. They break down and they're going to form that NO and O. And that O goes on to form tropospheric ozone. Remember that ozone is good up high, bad nearby. So when it's forming in the troposphere, it's close to us, it's bad, and therefore it's not good. It causes respiratory irritation, and that NO is going to react with VOCs, and all of that's going to create photochemical smog. So it's a solution to that: limit vehicle emissions. If you want to take a screenshot or you want to write that down, I 100% guarantee you that something related to tropospheric ozone is going to be on your test. So just be familiar with those acidic forming formulas, right? We either have CO2 or NO2 or SO2. All of them react with water, either in the oceans or water vapor from the clouds. And we're going to get out either carbonic acid, nitric acid, or sulfuric acid. So those are some chemistry that I would really recommend that you review and you cover. And I have a website, schoolofshap.com, and on there is a chemistry website, a chemistry review that you can get out and review. So yeah, I can absolutely share. Oh, sorry. I can absolutely share the slides. I'll share them at the very end. Okay, math. I know that this is the scariest part of math. Everybody hates it. but it's going to be really easy. We really only want you to do 3 formulas. That's all you got to remember. Rule of 70, this tells us how long it takes the population to double. The population growth rate, this just tells us how fast is the population growing. Births plus immigration minus deaths plus emigration divided by the total population times 100. We can take our formula, or we can take the value that we calculate in our population growth rate, and we can plug it into our rule of 70, and that will tell us how long it takes the population to double. So those 2 formulas are related. And then the last one is percent change. And whenever my students see percent change, they always groan and they're like, no. And so that's a really great way to remember that percent change is new minus old divided by old times 100. Okay, so again, the new value, the n, minus the old value, divided by the old value times 100. So all those olds are the old value times 100. If the number that you get is positive, it's a percent increase, and the number that you get is negative, that's a percent decrease. If you just write a 45% change, we will not give you credit. You have to indicate to us that it's a percent increase or it's a percent decrease, okay? Just a general reminder that you do get points for showing your work if your work setup is correct. Your work setup has to include units, and it has to show a cancellation of the units. If you set up your question incorrectly, you won't get any setup points. But if you set it up correctly and then unfortunately you just plug it into the calculator wrong, you will get full setup points. So each math question is worth 2 points, 1 point for the setup and 1 point for the answer. Make sure everything has to have units. If you take a look at what's on the screen, right, see how barrels of oil cancel, and then we're left with months cancel, and so we're left with barrels of fresh water per year, and that's kind of what our question's asking. Yeah, Brady's absolutely right. You need to show units. No units, no credit, okay? Here's a little math hack for you. If you are unsure, you're like, OMG, I got no idea what's happening in A, but you know that you need to take a value from A and plug it in to B. So what you're going to do is make up a value for A, make it 1, make it 10, make it 100, whatever you want it to be, make up that value. And then you need to say, you can even say, I made this value up because I don't know how to do A, but then plug it into B and solve B correctly. You'll get full points on B. We want to give you points. Okay, so if you just plug in for B and you have B entirely correct, we're not going to take off points that you didn't understand how to do A. We are going to give you full points for B. You can bring in a calculator. There's a list of approved calculators on the AP website. If you know how to go in and kind of store some stuff in calculators, you're not going to have to clear them, but you really just need a little 4-function calculator. So you do need a calculator to make sure you show up tomorrow with a calculator. The dimensional analysis can be all one big setup, or it can be multiple steps. We don't care as long as you're having units. If your units don't cancel, we're not going to give you credit. All right, let's keep going. We do have a couple of other math things that we should remember. One of those is the 10% rule, and that's just telling us that 10% of energy transfers from one level to the next. We can talk about productivity. Productivity is how much photosynthesis is taking place in an ecosystem. And we calculate that by saying the net productivity, how much is left over from the plant, is equal to how much the plant makes versus it's minus its respiration loss. And respiration is just how much energy does the plant use itself. The plant has to make its own flower. It has to make its own immune system. It has to move towards and away from the light. So that all of that takes energy. So our productivity, the net primary productivity, is how much the plant makes. It's GPP minus its respiration loss. Okay, and then we can, just like we can do that for producers, we can do that for secondary consumers, primary consumers, secondary consumers. All of that is called secondary productivity, and it's the same. The net is equal to the gross minus the respiration, but this time we have to calculate respiration, and that's the amount of food that it takes in minus its fecal loss. Okay, and then the very last one is, sometimes we see this on the exam and sometimes we do not. It's total energy used. Yeah, I see somebody says taxes, right? Like if you have a job, you know exactly about this. You get an amount at the top of your paycheck and you're like, dang, I worked really hard. And then the government comes in and it takes out taxes and you're left with a smaller amount. That's the net. So your gross pay minus taxes, you're left with your net. Same idea here. The plant makes a gross amount, it uses some of it, and we're left with the net. You just can say R. We know what R is. So again, we're all APES teachers or APE people that teach something equivalent in college. So you don't have to define things for us unless the question says define, and then you probably should give a definition, but that's not really a trigger verb. We're not going to see that. So if you use a vocabulary word, we'll know what it is. I do want to caution you, don't use shorthand, like don't put FF for fossil fuels or GHG for greenhouse gases unless you've told us first that you're using it. So the first time you write out greenhouse gases, in parentheses, GHG, then you can use GHG the rest of the time, but you should not use abbreviations unless you've defined them first. There is no formula sheet in APES, okay? The last one that we should talk really briefly about is just total energy. This is kilowatts times hours. Sometimes they'll give it to you in watts. You got to be really careful. Remember that there's 1,000 watts in 1 kilo. So kind of just be careful, watch your units, know your metric conversions. Metric conversions are super important. Okay, I'm trying to just double check. I've gotten most of the answers about dimensional analysis. I think we'll finish in enough time for you to do some general Q&A towards the very end. All right, graphs and figures. Number 2, FRQ number 2 is going to have graphs and figures for you to look at. You may even see them in question number 1. The big thing to remember is that you need to remember dry mix. Dry, the dependent variable, is the responding variable, and we're always going to see that on the y-axis. Mix, the manipulated variable or the independent variable, is always going to be on the x-axis. And so those are really important to remember. In number 1, it's going to ask you, what is the independent variable? It's going to say something, either independent variable or dependent variable or question. Copy the terms that they're using in the prompt directly onto your paper. So if it talks to you about aluminum toxicity as it relates to pH, you want to copy down and say the independent variable or the dependent variable is the concentration of toxic aluminum in soil samples. Whatever the verbiage that's used in the prompt, you want to use in your answer because it's usually pretty specific. So just kind of go through and make sure that you've matched up what's in your answer to what's in the prompt. I saw one question about CFCs. Yeah, you can use that abbreviation. That one's fine. All right. So dry mix, dependent variable on the y-axis, independent variable on the x-axis. When you're looking at a figure, please identify, look at the legend, look at the title, look at the axes label, and then make an interpretation. Make sure that you've looked for patterns. I sometimes tell students, spend one of your 4 minutes kind of just saying, this is what the graph is telling me. It'll be helpful, but don't overthink it. Sometimes we're really just asking, what is the value off the graph? I saw a question about dependent and independent variables. Dependent is the responding variable or the data. You can remember that because they're both D's. And then the independent variable is what the experimenter, is manipulating. If they ask you about an experimental setup, you probably should talk about the independent variable, talk about the dependent variable, and then also a control. The control is like part of the independent variable that's most like normal conditions that we compare our results to. Okay. Moving right along, somebody asked about legislation. So let's go through legislation. I've got 2 slides of legislation. The first one that we have to know is the Clean Air Act. The Clean Air Act regulates emissions of pollutants into the air. This regulates 6 criteria air pollutants. And I use the phrase nose clip in order to help me do this. I'm putting it in the chat. So nose clip. N stands for NOx, O stands for ozone, S stands for SOx, C stands for carbon monoxide, L stands for lead, and P stands for particulate matter. So nose clip can help you remember the 6 criteria air pollutants that are regulated as part of the Clean Air Act. And it's pretty specific. You need to know that. I want to draw a little star or a little, yes, you do need to back up your claims with evidence. I want to put a little star. Carbon dioxide is not regulated under the Clean Air Act because everybody releases carbon dioxide. So if we tried to regulate it, we'd have to try to regulate like animals breathing, and we'd have to try to regulate like forest fires, and we can't do that. So currently, carbon dioxide is not regulated. It is not considered to be a pollutant. Do not list it. If it asks you one pollutant, do not put CO2. Yeah, you can absolutely use SOxes and NOxes and CO2. You don't need to write those out. The Clean Air Act regulates how water looks. It prohibits people from dumping things into the environment. The next one is CITES. CITES is regulating the international trade of endangered species. And so this just note that Clean Air Act and Clean Water Act are United States laws. CITES is an international agreement that kind of prohibits the trading of endangered species. CERCLA. So CERCLA stands for the Comprehensive Environmental Response, Compensation, and Liability Act, but you don't have to memorize that. I would just memorize CERCLA. A couple of notes. We don't care about spelling on your exam. We do care that you spell the abbreviations for legislation correctly, because if you don't spell CITES correct, then we're not sure what piece of legislation you're talking about. You won't get any credit. So please make sure that you're spelling CITES correctly, you're spelling CERCLA correctly. So this basically charges companies that produce hazardous waste, and then the government holds on to that money. So in case there's an accident or a spill, then they use that money that they've taxed in order to clean up the contaminated sites. The next piece of legislation is the Montreal Protocol. If it says protocol, it means international. So Montreal Protocol is an international agreement that phased out and eventually banned CFCs. And this one's been largely successful. I sometimes feel like apes is super like doom and gloom, but you know, this Montreal Protocol has been successful. And so what we're seeing is that the ozone layer is totally kind of repairing itself. It's going to take another 50 years, but it is repairing itself. What we also see is that we have the next one, we have the Kyoto Protocol. Kyoto Protocol is just an international agreement that limits greenhouse gases. The United States did not ratify Kyoto, so we don't kind of participate that, but everybody else is trying to lower their greenhouse gas emissions. All right. Legislation, we have the Endangered Species Act. This is a local piece of legislation that regulates endangered species. The Safe Drinking Water Act regulates how much pollutants can be found in your drinking water. And I'll give you a hint, the answer is not 0. And then the Delaney Clause. Delaney Clause is super old, but it pretty much just says you can't put cancer-causing things in people's food. That's not allowed. And then the last one is RCRA. This stands for the Resource Conservation and Recovery Act. This piece of legislation regulates landfills. So I'll make this presentation available to you guys when we're done, and maybe Marco Learning can post it for us. And so I would just go back and totally review. I also have these and I'll review PowerPoint that's listed on my site, and my site is schoolofshap.com. All right, we're kind of towards the end. We have about 10 minutes left. I'm going to end around it's 6:45 Eastern time. These are the top 10 things that I think you should study tonight. The exam's going to come out of the what we call the course and exam description, which is available on College Board's website. But these are 10 things that I consistently write questions about that are consistently on the exam. So the first one is, how is electricity produced? Okay, do not talk to me about creating energy. Energy is not created or destroyed, it's just transferred. So how do we get that electrical energy, right? You talk about the turbine spinning, and that turbine is attached to the generator, and the generator converts mechanical energy into electrical energy. So be able to say that in specific detail. That's a multi-step process for you to earn that 1 point. Eutrophication. We love to ask about eutrophication. It's always on the exam. So making sure that you understand that fertilizer runoff leads to algal blooms because of the phosphorus, and then that blocks plants and everything kind of begins to die and decomposition occurs. And there from then, those decomposers use oxygen in the water. And so DO levels fall and we get kind of this hypoxic or dead zone. The AP exam loves wetlands. Why humans like both, what are the functions of wetlands and how are humans impacting them? And so we're going to ask you some questions about wetlands. We love to ask about soil erosions. You 100% need to be able to use a soil triangle. Okay, I'm sure Mr. Smedes has a video on soil horizons and soil triangles, so be sure to check that one out. We need to know about air pollution and solutions to air pollution. We talked about few of them today. Most biggest one, limit how much you're driving cars. We need to know about the parts of a landfill, and that's going to kind of go back to soil. So those are really important. We need to know the functions, impacts, and solutions to dams. The AP exam doesn't really love dams. We're not really huge fans. And so being able to talk about the advantages and disadvantages of a dam is really important. Okay, we have 3 more. Climate change, 20% of the exam. So be able to talk about the causes and solutions to climate change. We like to talk about population growth and the importance of educating women. And last but not least, agriculture. So being able to discuss the industrialized agriculture system, what kind of things are we putting in and what kind of things are we getting out? All right. I know you guys have worked really, really, really hard all year. So I'm going to take about 5 or 6 minutes worth of questions. Just go ahead and put them in the chat and I'll try to answer them as fast as I can. I know that the first one I see is CITES. That stands for the Convention on the International Trade of Endangered Species. CERCLA is the Comprehensive Environmental Response, Compensation, and Liability Act. Somebody asked about setting up dimensional analysis. My big hint, start with what they're given. Okay, so if they ask you, if they say that you use 900 barrels of oil, start with 900 barrels of oil and then cancel your units out until you get the units that the question asks you about. Okay, I see some questions about SOx. SOx is really SO2, SO3. We just refer to it as SOx, and that's going to be fine. I know that you guys are going to be great. You're going to rock tomorrow. Remember to head over to Mr. Smedes' channel when we're done. And make sure to check out his videos. Be sure to check out the AP Daily Live review sessions done by Mr. Fassler and Mrs. Fassler and Mr. Villarreal. And there's going to be super helpful. Wetlands. Somebody asked about wetlands. Wetlands are areas of land that are wet. They are really important in nurseries, so animals go back to spawn there. They're really important in flood control. They're really important in water filtration. They're really important in nutrient cycling, and we're draining them and we're developing in those areas, and then those areas tend to flood, and then humans are impacted by that flooding. Somebody asked the difference between HCFCs and CFCs. One of them has an extra hydrogen attached to them. That's kind of beyond the scope of the course. I would just know what are CFCs. We should know how they impact the ozone layer and the piece of legislation that regulates them. The FRQ number 3 is for sure going to have math. It's for sure going to be dimensional analysis. It probably won't just be percent change. It's probably going to have dimensional analysis. It's worth 6 points. But that also means that there's 4 points of non-math work in your number 3 math FRQ. So make sure that you answer the non-math portions of the math test, the math FRQ. Scrubbers take out SO2, and I remember that because they both start with S's. So you're only going to see math on FRQ number 3. There will be a couple of questions on the multiple choice that ask you about either which is the correct answer or which is the correct setup. You don't need to show your work for those. Go-to responses in FRQ, habitat destruction that leads to a decrease in biodiversity. Yes, Riva, definitely the demographic transition model for sure. How is the changing status of women impact that? Will you have to bubble your answers on the answer sheet? Yep, and remember, no eraser mistakes, so be really careful. What else? El Nino and La Nina. So El Nino, normally trade winds that blow, I have to always do this, east to west, actually stop, and they sometimes reverse. This suppresses a cold water upwelling. This results in less nutrient availability and a collapse of the food webs, which impacts the fishermen. La Nina is just an exaggeration of normal conditions. So that upwelling that's normally present is really cold and really strong. Soil horizons. We're going to start with, at the top, we have our organic layer. This is our humus layer. Then we have topsoil, that's A, B, then we have E. This is the zone of alluviation where nutrients are just going to move down. And then we have our B, which is our nutrient layer. Our mineral layer. Then you have C, which is parent submaterial. And then you have parent material. Each FRQ, first one's going to be about experimental design. Second one's going to be about data tables, graphs, or visual diagrams. Third one's going to be math. Amanda, we don't know those kind of things. How many multiple choices do we need to get a 5 We don't know. They don't release that. Just do your best. You guys have been working really, really, really hard all year long. Go in with a clear mind. Do not second guess yourself. Go with your first instincts. It's almost always correct. You should spend about 20 to 23 minutes per FRQ. There's 3 FRQs in 70 minutes. All right. How do we write an experimental design FRQ? It's just going to ask you. You don't have to write it. It's going to ask you, what is the independent variable? What's the hypothesis? What is a variable that wasn't considered? So you're just going to answer the questions that it asked you about the experimental design. I know that Mr. Smedes has one. I also have one that's on my YouTube channel that I'll link here at the end because I don't know it off the top of my head. Smokestacks are really tall smokestacks that usually emit actually water vapor into the air. They're not usually emitting pollutants. I think we're in normal no, maybe we're in an El Nino. They're not going to ask you years. They're going to ask you, describe an El Nino events, steps of an El Nino, or what are the environmental impacts of an El Nino. And then you can talk about nutrient cycles being, or nutrients being suppressed because the upwelling is not there. Therefore, fish or plants don't grow, and therefore the fish don't grow. So you can talk about those. Some areas experience huge droughts, like in parts of the Pacific, go through a big drought during an El Nino versus other areas that get more than normal amounts of water. So that's kind of what you should focus on when you're studying El Nino. Hadley cells, polar cells, they contribute to winds. They're due to the Coriolis effect. That's kind of it. Do you need to know what sites and CERCLA stand for? Absolutely not, as long as you can spell them correctly and you know about the legislation. But we're not going to ask you which of the following is the correct term for CERCLA. That's not something we're going to ask. Yep, Jamie is absolutely correct. We don't know. It's different every year. And we try to set you guys up for success. We want you to be successful. So we try to break the curves so that the most number of people can pass. All right, you guys, I am going to shoot. Let me see. I can put this here. And I'm going to throw this in the chat. I'll also give it to Marco Learning so that they can put it up and have it for later time. It's been such a joy to be here with you guys tonight. I'll post a few additional links and have Marco Learning post those for us. So good luck studying tonight. Don't stress, you're going to do great.
Thank you so much, Ms. Shapiro. Real quick, as we wrap up and send you all over to Mr. Smedes, tell us about the School of Chat page. Where should I go? I popped this link in the chat. I'll put it in the description. What are the best things that you have on here for APE students?
For APE students, I don't have a ton, but if you do scroll down and you click on that button that says review, and we open that up, I kind of have a little bit of a folder that's got some review stuff on there.
Amazing. So check that out. That's schoolofshap.com. And if you're an APES teacher, definitely check out the resources that she has here. One other thing I popped in the chat earlier is our test day checklist with this, just all the information you're going to want going into the exam. And then let's actually, within this live, look at this live, which is the Smedes live that got started a few minutes ago. Check out Jordan Smedes' channel, Apes versus Everybody. You can say hi in the chat and join Mr. Smedes. So head over there now. Thank you all for coming and have a